Hello, this is Captain Chaudhari in my series of videos on marine astronomical navigation. Today, I'm going to talk about time. What is this time? What is a time in general? Broadly, the time can be divided in sidereal time and solar time. Sidereal time is simple. We know if this is celestial sphere, this is equinoctial, and this is ecliptic. This is the first point of Aries. Now, on the polar diagram, we might have, this is the pole, we might have an observer over here and Aries over here. So this angle is called LH Aries, the westerly angle from observer to first point of Aries, and LH Aries divided by 15 is local sidereal time. So local sidereal time is a concept. Local sidereal time, basically we don't have clocks. You might call it a sidereal clock or astronomer's clock, but we do not see them in practice. It's a concept. Like if somebody says local sidereal time is 5 hours, 5 multiplied by 15, that is 75. 75 degrees is LH Aries. On the same line, we can say GHA Aries upon 15 is equal to GST, Greenwich sidereal time. Solar time is of two types once again, apparent time and mean time. I sometimes ask the students, how many suns are there in the sky? So sometimes you won't be surprised, you get funny answers like you have true sun, you have mean sun, we have apparent sun, we have real sun and dynamic sun. So basically please remember, there are only two suns in the sky. One sun that we see, whether we see it through binocular or through shades, but that is the sun, that is the real sun or true sun. And there's another sun which we do not see. The other sun which we do not see is an imaginary sun, which is slightly forward or slightly behind this true sun. And the difference is measured at pole as equation of time. So basically there is only two suns, there are only two suns, one which we see in the sky, there is a true sun, and one which we just imagine. Okay, now what is this apparent time? Apparent time means, so many books, they say, the time is measured from inferior meridian. Time is measured from the lower meridian. No, I don't want to trouble the lower meridian. I don't want to talk about the inferior meridian. I have a simple formula. Whatever is LHA of true sun divided by 15 plus minus 12, you will get LAT, local apparent time, is given by whatever is LHA of true sun divided by 15 plus minus 12, right? And on the same line, we can say that GAT is equal to GHA true sun divided by 15 plus minus 12. That's it, right? We know what is our angle, LHA true sun or GHA true sun. Both are our angles which are measured westward. LHA starting from the observer's meridian and GHA starting from the Greenwich meridian. These are the westerly angles. And once we know what is LHA or GHA, we can divide them by 15 and then we have to just do plus minus 12. Why should I talk about the inferior meridian? I don't talk about inferior meridian when I'm talking about the time. So I hope you understand what is LAT, what is GHA. For example, let us say this is the celestial sphere I see from top of north celestial pole, and this is the observer, this is observer's meridian. On this north polar diagram, the sun moves westward at the rate of 15 degrees per hour. When the sun is crossing observer's meridian, right, the sun is overhead. For example, if you put a pole on the ground, the moment the shadow of the pole is smallest, we say that sun is crossing observer's meridian. The shadow smallest would also mean that altitude at that time is maximum. and zenith distance is minimum. Apparent time is what you can make out looking at the sun, what appears to you. So when any person who's walking in sun, he looks at the sky, he says that sun is at maximum altitude, maximum height, sun is overhead. That is the moment we would say that it appears like the time, the local time is 12 o'clock. Apparent time is based on the position of the true sun. When the true sun is on your meridian, crosses your meridian, that is the time, it is 12 o'clock. So whether you are in northerly latitude or southerly latitude, sun is crossing your meridian means local apparent time is 12 o'clock. Okay, this also means that local apparent time on the inferior meridian is midnight, right? So now the question is, why do we do plus minus 12 hours? Why there is a discrepancy of 12 hours? It is like when sun crosses your meridian, right? You don't want the date to change. You want the date at any place to change when most of the people in that territory are sleeping. So you want to change the date, when it is about midnight in that place, not broad daylight, not 12 o'clock. So that is why we maintain a discrepancy of 12 hours, this to avoid the domestic problems. Otherwise you will have confusion. If a flight has to take place on 15th or 16th noon, you wonder whether it is the 15th of the previous day or it is the 16th the next day. Out at sea also, we alter the clocks when the people are sleeping, Okay, so the plus minus 12 hour is for that reason. So when you divide it by 15, if the value comes as less than 12, then you can add 12. But if the value comes more than 12, suppose I have 165 degrees as LHA, I divide by 15, I get 11. So I will add 12. But suppose it is 300, I divide by 15, I get 20, so I must minus 12. Simple. So there is no confusion with that, whether to add 12 or minus 12. So let us understand that we are able to measure the local hour angle. For example, if the sun is over here, this LHA is 90, right? 90 divided by 15 plus minus 12 will give you 6 plus 12, 1800 hours. So when the sun is in this position, the local apparent time of this observer is 1800 hours. What is mean time? So LHA mean sun divided by 15 plus minus 12 is LMT, and similarly GHA mean sun divided by 15 plus minus 12 is equal to GMT. So basically, what is this mean time, and what is this mean sun, we'll chalk in a while. But at the moment, I have written it here just to understand that the way I find out LAT with the true sun, I find LMT with the mean sun. True sun is what you see in the sky, and mean sun is something which you have imagined. What are the problems associated with true sun? So suppose we talk about a territory, suppose we talk about India. Suppose they say that let us maintain the time looking at the true sun directly. The moment sun crosses your meridian, you change your clock to 12 o'clock. You maintain the local apparent time, and next day when sun again crosses your meridian, most probably it will be again 12 o'clock because sun takes 24 hours to come back on the same meridian. But the problem with this will be like every meridian will have a different time, different solar time. So we'll have a lot of problems. Problems in respect of communication, problems in respect of keeping the meetings, the travel time, the air schedule, etc. So we cannot do this. The apparent time is out of question. See, the basic problem is, if we look at the celestial sphere this way, that let's say that this is equinoctial and this is ecliptic. We know that sun moves on the ecliptic. This is 21st March, 21st June, and over here you have 22nd December, the position of the sun. Like sun moves on ecliptic, right? And the problem is sun moves on ecliptic at varying speed. But we know that sun moves on ecliptic, but the time is maintained or time is measured on equinoctial or the celestial pole. So this is the time axis and this is the time base movement axis. Sun is our time base, and that sun, the time base, moves on ecliptic a different direction. What we basically want is this true sun, which is moving on the ecliptic at varying speed. If we have a mean sun which moves on equinoctial at uniform speed. Only thing is, suppose you have true sun here and mean sun here, and while measuring their meridians or difference in their meridian, which is called equation of time, if we are somehow aware about this equation of time, we would say, okay, here is the position of true sun, but we know the equation of time, so we also indirectly know the position of mean sun, from which the time can be decided for any territory or the global time itself, right? So what is necessary is, as the true sun moves on ecliptic at varying speed and it takes a certain amount of time to complete one revolution, right? You imagine mean sun, the total time taken by mean sun to go around the equinoctial is same as the total time taken by the true sun to go around the ecliptic, and mean sun moves at uniform speed.